Hello, hello. Test. Sound 1 2 1 2. Will come 20 seconds later. Still nothing?
Yeah.
It's coming, right?
Yeah.
Okay. Hello, everyone. Welcome to a second session of our Semantic Kernel series. So, if you remember, last week we stayed here the function calling part of the semantic kernel. So today we are going to continue from this part, function calling part, and get into the details, and we'll learn some other details of this function calling part of this semantic kernel, and then we'll continue with some AI services in the semantic kernel, and also we will see some enterprise services that you can use in the semantic kernel. Okay. Let's one more. Let me order the pizzas also.
Do we have any charging slot here?
In the ground. You found it?
Yeah.
Okay. So the most powerful feature of this semantic kernel is automatically identify the functions in the methods, in the plugins that we register to the semantic kernel, and automatically call them. That's one of the strongest function or feature of the semantic kernel. Okay, so this will allow us to build chatbots or other applications easily and very fast compared to the other frameworks. Yes, agents and plugins, exactly. So the aim of the semantic kernel, as I mentioned in our previous lesson, abstract this process for us to make this development easy to develop. That's one of the first aim of the semantic kernel. But
Hi.
Hello, welcome. But we need to understand what's going on at the background. So we will get into the details of how this function calling is working at the background. Okay. So this is what's happening at the background when we do a function calling with semantic kernel. In the first step, take my laser pointer here. First of all, semantic kernel automatically serializes the functions for us. It's used the JSON serializer at the background. It will take those methods, C# methods, and serialize them as JSON. Don't forget there are different ways of defining the plugins in the semantic kernel. The one that I showed you is just a C# method. That's the one of the way. Another way is there's a conventional way to define the plugins using a directories called plugins, and then define your plugins in that directories. That's the second way. And you can also use this YAML syntax or templates, prompt templates to define the functions. But at the end, whatever methods you choose, at the end, all of them is serialized to a JSON format at the background. That's the first step, serialization. All of the available functions and their inputs are serialized into JSON format. That's the first step. In the second step, this is the first step, right? Serialize the functions. In the second step, we send the messages and functions to the model. So the serialized functions and the current chat history are sent to the model as part of the input. So we send it to our model, okay, with the history. Then in the third step, model process the history input. Model process the input with history and generates a response. So the response, this part is important. The response can either be a chat message or one or more functions call. So response can say that this information that I received from the user is not enough to respond back to the user yet. So I would like to do another function call to answer the questions of the user. So it will go into fork here.
Number 3 being internal communication.
Yes, it's internal. So you will not see anything. Okay, it's internally decide. This model decide if the information that he has is enough to respond back to the user, or it needs to call another function or not. Or maybe he decides that the current available function list is not enough to answer the user's request, and he can return and say that, sorry, apologize, I cannot answer your questions with the current functions. So there are 3 different outputs from the step 3. Okay. So in the step 4, either handle the function response, extract the name and parameters, and invoke another function. For example, in my sample, I have a function which will return the weather information of a city. Okay, that's one method, get weather information. If it's cloudy, if it is snowy, it's raining, so on and so forth. But it will take a parameter of city name, for example. And I have another function which will automatically identify the location of the user, for example, right? If, so for example, I ask the Copilot or AI, give me the weather information of my city. It's supposed to ask me the location of my city. If he couldn't get this location, he cannot return back this information, right? That's why he will come here. He will return and say that, give me the location. Then it will go to invoke another function, right? It goes to the first, give me the location of the city, and it's a loop. So first it will take the location of my place. Then it will call the weather information of this location. Then it will return back to the weather information. So this loop will continue until it gets the information from me, which will enough to respond back to me. Or it will return back to me an exception, says that, sorry, I couldn't get enough information to answer your question. Yes, it can be one or more API calls.
One to get the city and one to get the
weather information, yes. And it will do it by automatically at the background. Okay. If the information is enough in this step, then it will return back to response to the user. Okay. So let's do a demo. In this demo, I will do I prepared a pizza ordering system, which will OpenAI help us to give me an order from the pizza ordering system. Okay, So let me go out from this and I will open my pizza service. Okay. And let me zoom in. So what I have two applications. One of them is console application. Okay. This one. One of them is console application, and the other one is my service application. Yeah, simulating a pizza ordering service. Okay. And console application, what I am doing is, as you remember from the last week, I just introduced my AI, Azure OpenAI service. Okay. My model name, my endpoint address, and API key. Okay. Then I create my kernel, semantic kernel. Then I said that I'm going to use the chat completion service with those parameters. Okay. Then I am registering the services. So I have three services here. Pizza service. The type of the pizza service is iPizza service. User context and payment service. I have three different services. And then I add them as a plugin. Then I also add a logging service because I want to see what's going on at the background. I want to see the traces. What's happening, how this semantic kernel is calling the methods at the background. I want to understand what's going on. Then I will build it. I have chat history. Then I define my function choice behavior as auto. It means I'm going to explain this one. It means that go and automatically call the functions by using their names or descriptions. And then I get into a loop and then I collect the user information by console and add this to the chat history. Then I call the kernel. And it's a loop until user enter exit or enter a null message. Then I will go out of the application, exit the application. So that's the first one. What about in what I did in this service? The first thing I defined my interface because if you remember, I said that in our last week lessons, I said that we are using this kernel is using dependency injection. And you know, in the dependency injection, the main concept is the contracts. And in order to define the contracts, we are using interfaces. So that's why I define my interfaces. In my user context, I have my get cart async. This is my cart. It's like a basket. I have my pizza service. I have multiple methods here. Get menu, get pizza from cart, add pizza to cart, remove pizza, and checkout. And payment service, request payment from user async. This is my interfaces. And then I have models. In the models, I have my objects. Menu object, pizza object, pizza size, this is enum, pizza toppings, cart, and remove pizza response, checkout, pizza response. And finally, I have my services, payment service. Normally, I'm supposed to go to the payment system and I will do a checkout operation here, but I am simulating here. I'm just doing a task delay for 1 second and then I return a new GUID. Just simulates that I'm getting money from the cards, okay? And then in the pizza service, I have the menu, right? This pizza service is inherited from the iPizza service. And I have this payment service and user context here. and I implement those methods. So I check if cart is null, and then I create a pizza. Then I will add this pizza to my cart. Then I return the cart. So I'm not going to explain all of them, but the important part here that, again, I mark them as kernel function, which I announce them to the semantic kernel that this is the function that it needs to use if it wants to add a pizza to the cart. A description part, and you can also say which one was it? Yeah, let me see. Yes, description, the return description, the updated cart after adding the pizza. Okay, so I did this for all the methods. Get menu async. This is like a dummy menu. I have 3 items in the menu: pizza, get pizza from the cart, and remove pizza, and payment service and user context. This is the user context. This is my constructor, and then get cart async. Okay. So let's try how this one is working. I will open my console. Are you able to see it? Yeah, it's much better. Then I will go into the pizza, .net. Okay, so what's happening is it first goes to the pizza order services, and it's adding all of those methods, functions, to my function list. You say add pizza to cart, checkout, get menu, get pizza, remove pizza. You say created plugin for order pizza with 5 kernel function method out of 11 founds, right? User context, 1 kernel function. Request payment, 1 kernel function again. Okay, so it explains everything, and then it gives returns back to me as a user and asks me what I want to do. Okay, so I'm gonna say that may I see the menu? So what happens when I say that may I see the menu? It goes to here, OpenAI. You see, this is my chat history. The role is user. It automatically takes my input and it adds this input as a user into my chat history. And this is the text. And then you see the function calling method is type is auto. Then auto invoke true. You see these are the functions that is available. Then it will go and call get menu. Okay, it will go and get menu, and these are the results. And it also adds those results into the history. And then it gives me the list of the menu. If you would like to place an order or have any question, feel free to let me know. So I will say that I want second pizza. Now, if you check the history, you will see that my history will also include the menu items because it was part of the return type. And it generates an error here also. Let's see what happens. That's why the logging is important. So it's here, it says that, let me go up to understand what's going on. So I want the second pizza. This is the chat history. You see all the menu items are also here. Then invoking what? Kernel function get card completed. Payment false. Why? Order pizza, add pizza to cart failed. System string cannot be converted. Type system collection generic model pizza toppings. Most probably, and it failed multiple times. You see, this is the second fail. What's that?
Which is the second reason I have something asked. When it comes to the parameters and the functions, what do you actually always get the good language?
Yeah, that's why. Maybe that's the reason. It couldn't.
This is 2, maybe, right? Second, right?
Yeah. So that's what we need to understand.
The error is showing that like 0, up.
Where is it?
Up, function callback.
Here.
Up here, down there.
Functions second. This one?
Yeah. Very smooth. Every 1, 2, 3. It's integer string.
Maybe. Function index invocation function invoke kernel.
That you get that minor instance.
But it says system can convert cannot be convert. No, it's toppings. So the toppings is a list of items. If you go here, look, you will see that in the pizza service, yes, can you see the add cart? You see add cart to pizza. This is the list pizza toppings. It's not string. It's a list of toppings, and it's a enum. Most probably, it cannot convert the second pizza from string to enum. But
It chose the first function to put the pizzas, and then took it as a string, as an alias.
let's try. May I see the menu again? But this will increase the, let's do this, let's exit. It will increase the number of the tokens, and then let's go out and try again. Yes.
As you use it, the token consumption.
Yes. Yes. So there are some best practices that I'm going to talk about after this demo. That's one of the things. So you need to be very careful what you're going to keep in the history or what you are returning back to the end user. There are things that you can do. For example, when you return something, maybe you can, instead of adding everything to the history, you should use a summarizer instead of adding everything to the history. For example, maybe use another method to call summarization, or maybe you can limit the length of the return. It's up to you. Yes, you will keep it, or maybe you should decide what you're going to keep in the history or not. Maybe you shouldn't keep everything in the history. It's up to you.
Two pizzas had one topping and it wasn't able to convert that
Yes.
to a list of one element.
Yes. Let's try again. The funny thing is that when I was trying it, when I tried to order the first pizza, it was failing. And then when I tried to order second pizza, it was successful. But now when I called the second pizza first, it failed again. So you need to do a proper testing. And you need to try to handle all the cases when you are developing with this semantic kernel. So let's try this. I want to order pizza 1. Let's try. Failed. It seems that there's a technical issue. Okay, again it failed. Same system cannot be converted. List pizza toppings. Yeah, so let's try this one. I want to order pizza 2. Let's try pizza 2. No, failing. So card, pizza, size medium, toppings, cheese, price 10. Failing. Let's try. How about adding pizza 3 into my cart? No, still. Pepperoni.
Description. So that it specifies that this has been described with another change to a different string value.
So,
The description.
okay.
Is it topic must
Tell me. Pizza, toppings must be of type or must be type of pizza toppings. Okay, let's try. That's a good point. Toppings. Did I save? Yes. Okay. I want a large pizza with pepperoni. Let's try this one. I want to order pizza 2. No. So this one somehow couldn't convert this cheese, pepperoni, mushroom. It's an enum type. And in my menu, yeah, it calls to get menu. And this is again the same type, pizza toppings. And it's using this enums also. But still, it couldn't convert the type. Let's try to do it from here. So, for example, if I put a breakpoint here, and if I go to debug, Now we are in the debug here. Let's try. May I have the menu? You see it gets into the menu. Stop here. So F5 to control. It returns the menu for me. So I would like to order menu item 1. Let's try this, huh? No, still it couldn't find it.
Takes it from the history. That's why.
How did you understand it?
That's why the get function, right?
Yes.
So it is from the history.
Yeah, but will that impact?
That physics is stream.
That's a good point. Okay, then what we can do is, that's a good point. Yes, so what we can do is, so use this, then we can do this one. Let's add this one. Check out async. So where are we gonna put this one? In the menu, get menu, or to here? Returns this method ordering pizza. That's
not passed by the get menu function. So
what's that?
it's not passed by the get menu function. So it never the second.
So maybe we can do this, huh? Get the list of the pizzas from menu. What do you think? And add the selected pizzas to the cart. Let's try this. Save. Do I need to change the menu function?
Description built from the menu function.
I didn't get it. I didn't get you.
The one which is change the form, so the description. So saying that we need to say that menu function. But the state for that.
Okay, let's try. Okay, and 5. Okay, I would want to order menu item 2. Yes, which one? Now it reaches to here. Still, this one now pizza toppings is mushroom. If I go to variables here, toppings is cheese, sorry. Now it's a list of cheese. Okay. Now that was good. And if I make F5, so the medium cheese pizza has been successfully added to your cart. Now, would you like to proceed to checkout and or add more items to your order? I also want to add pizza 1. Yes, it's going to be, but still, it's not going to get menu. It's not calling to get menu. Yes, because I have a breakpoint here in the menu. You see, it's not reaching here. Still, it's reading from the history, but I don't know if description might impact. Now I have two items in the list. So let's say checkout. It will go to the checkout. Yes, now I'm in the checkout. And that's it. Enjoy the meal. Okay. So as you can see, description part, the name of the function is important. It impacts the behavior of the application. So you need to be very clear. So there are some best practices here that I would like to share today with you. So let me return back to the,
Very important to consider the description.
as you can see. Yeah.
What's really right? Also change the system message by okay, so that your name system, but you only use the API functions.
Yeah, might be. Yeah. Yeah, correct. Maybe this will be more effective because this might be reduce the number of the tokens also if you have a proper system message. Instead of writing the long descriptions for each function, writing a proper system message will reduce the size of the tokens, the number of the tokens that we are using. Yeah, that system message. This is the message that you explain the AI what is his role, what's its role. For example, you are a health center agent, so you will limit the type of the answers that this agent can give, right? It's a role. You remember in the previous week, I said that there are different roles. Yes, one of those roles is system role. So you can give it with the system role into the history. What is that? How do you? This is one of the best practices. We always limit the card lines of your AI agents. Otherwise, it will go outside of the lines.
Also to count the distraction to I mean, instead of us question what should be the limits or what should be the right description in order for the agent to stay in the limits, what should we ask
What do you mean we as a user?
As the developer.
Yes, then this system message should be given by the developer, not the user.
Yeah, but developer, how can I get exactly like for example now, if I didn't realize that the problem was that it doesn't look well, it takes the window from the history. If I didn't realize this, how can I fix the error? How can
First of all, the system message should be given all the time. This is one of the best practices because you need to limit the AI that's or functions. That's the first thing. You should leave that one without facing these issues or not. Okay? And you might always have these problems, failures. So the best way to solve those things, you need to have a proper logging and always watch your application, always watch your logs, and when you face this kind of error, you need to try and fix those errors. Tracing, logging, exception handling, these are things that you always need to do. So it doesn't, so when you deploy an application, it doesn't mean that this application is done. It's working properly. You need to always operate it. You need to monitor it. You need to always audit it, right? Otherwise, you cannot improve it. This is not about, also, this is not only for this AI application. This is true for all kinds of applications.
I thought there could be a way of, like, as we are talking about it, this is the good idea of automating this process.
still we going to buckets. The odd ways with your code, there is no easy way to do it. I wish there is, but inshallah next time. Okay. Now, again, this is how the serialization is working at the background. Okay, when we introduce those functions to our application, it will automatically serialize these functions at the background as a JSON. As you can see here, let me use the laser pointer. As you can see here, there's my laser pointer. Okay. The type is function. The name is order pizza dash add pizza to cart. As you can see, it takes the name of the plugin or name of the class and use this one as a namespace, then the name of the method. Okay. So again, there is a best practice. You should always use a simple names for your plugins and simple names for your methods also, which I'm going to talk about. Description, parameter types. As you can see, it's enum. It's used as a string, array, topics, so on and so forth. That's how it's serialized. Okay? That's the serialization part. Only functions with the kernel function attribute will be serialized. Okay? The other functions in the model, the other functions in the class will not be serialized and will not be introduced to the model. So this allows you to use the helper methods hidden to the model. So the model will not aware of your helper methods. It will be hidden for the model. No, you shouldn't. Because you need to keep it as simple as possible, right? Only the necessary functions needs to be marked as a kernel function. Okay. So now let's talk about some of the best practices. The first one is verbosity of function schema. Okay. Keep your functions as simple as possible. Because these serializations, you saw that these serializations doesn't come for free. Whatever you serialize, it will be part of the history. And this history will cost you this token. And token will cost you money, right? So that's why, in order to save the money, you need to keep your function descriptions, names, everything as simple as possible in order to save the money. That's the first thing. The parameters, the name of the parameters needs to be as clear as possible, and the name of the parameters needs to explain what is it for. It should be enough explanatory what this parameter is for as much as possible. The one thing that you don't need to worry about is return types of the methods because they are not serialized. But the best practice here, the return times should be also as simple as possible. Otherwise, the AI model will not understand what this return type is for. Again, you need to keep it as simple as possible. Okay? That's the first best practice. The second best practice is parameter types. It's important for the model to understand expected inputs. For example, in our sample, what we use enums as a pizza toppings, right? We use pizza size, small, medium, large, instead of using string, right? String is not a good parameter type for the AI. Why? Because AI couldn't understand what this string is for. But if you use an enum, it can serialize and deserialize. It will be a meaning for it. Okay? And of course, you need to avoid argument types like GUIDs, because again, these argument types or parameter types will be part of your history and it will increase your token size. That's why you need to use simple types like integer or decimal instead of long grids. Okay. Required parameters will, you can also specify which parameters are required. And you will see that when you use plugins with a convention base, I'm going to explain it later. You can say that this parameter is required or not, or a JSON, you can say that it's required. In C#, if you don't mark, if you didn't mark a method as an optional or a default value, then it will be required, right? So you should explain that this parameter is required, and this will help the AI to understand what is necessary, what is not. For example, in order to call a method, it will understand what are the required parameters, and it will ask this information from you. If it couldn't get this information, it will not call this method. So you need to help the OpenAI to understand what is required, what is not. Function descriptions, they are optional. This description attribute is optional. But we are using them most of the time. Again, the best practice, if you can describe a function without this description, that's the best case. How are you going to do that? With name of the function, with the parameter types, with the parameter names. If you can explain it, that's perfect, because you will reduce the number of the tokens. But if you can't, then keep simple again, as much as possible.
Now I understand. It's like we are describing the function to the agent.
Exactly. Function to the AI service.
Yeah, AI agent.
So AI will understand. AI is using this description, using the function name, using the parameter names to call it.
And that's based on that they are calling it.
Exactly. It's using these namings. It's using these conventions, right?
The description of the function name is not enough to describe.
Yani, that's what I'm saying. The best scenario is not using the description. Use it at all, yes. Because you will consume the token. If you can describe it without the description, that's perfect. But if you can't, you need to put a description. This description needs to be clear and short as much as possible. Okay. For example, get pizza from cart. This method name is clear enough. You don't need to write a description unless you face an error. And how are you going to improve it? You need to trace it. You need to always log it, log to a logging database. Talk loudly, I couldn't hear you.
If I'm calling the function multiple times, does it read the description every time?
No, I don't think so. But when you, okay, so if you face a failure and if you call again, no, it will not be part of the history. It's only one time exception. Yeah, if you call them multiple times, yes, it will be part of it.
So every time you read the description.
Yes, that's why you need to reduce the, yeah. So there's a tip here. Before adding a description, ask yourself if the model needs this information to generate a response. If not, consider leaving it out, reduce the verbosity. Okay? You can always add the descriptions later on. So you can start without description, and then if it's not working, you can continue. Hello? Okay, coming. Thank you. Our pizza orders arrived.
Okay. Good that they don't check the function error.
Yeah. Luckily, they don't have any errors. Let me check Fatma is available on it. I believe she's in the meeting.
Okay, let me go and print design on the function. Very similar. No. Let's see 5 minutes later.
Can you explain exactly how semantic kernel role here? I mean, I really understand how it's how. Just want to try to understand how the main concept we are here to get us kernel relation, right? So just before it was like performance kind of stuff, what I did. So semantic kernel, what exactly is doing when it's all there?
The easiest example is the highest tier of ChatGPT comes with an agent. Okay, so basically you can ask this like this like a mediator on example like for example order pizza or order this pizza. For example, go to whatever pizza joint order from, go to their website and order from there. You don't have to do it manually. So let's say you have multiple services, you made your website to be AI friendly with this description and whatnot. And look at your browser and then you can description. Yeah, of course your browser can do that. But in this case specifically, you can have your app where it has it's like a shopping app, okay? And someone wants to order like anything, like a shirt. It's like, okay, order me this shirt. And maybe I think easier use for instead of typing, and take a voice and orders for you, and usually on your phone you have all the details like rank details, house description. I can get from your phone what's there, because everything automatically and how the previous process of like building the information. So especially it can fill forms and do stuff like that.
I think semantic kernel is doing behalf of you.
Yeah. Especially if you want to be extra busy.
Technically, it's like
It also helps for a little bit of creativity. Maybe you have a client, maybe you define multiple abstract functions, and maybe you can use those functions in specific combinations to get different results. In this case, depending on the user's input, the model will use basically different blocks to give the answer. Essentially.
so. Let's say it's like a kind of advanced feature of the gradient plus normalization.
From that you just talk to it.
Yeah.
But this one has
Just doing something we have to do.
yeah.
Yeah, your assistant.
It's assistant. You don't have to talk to it.
The lot of people. Sometimes we just go through, like for example, we just started developing this script, right?
Yeah.
So we thought it's something else, like with all of the time to come. So basic things like our assistants will try to do something they have to tell, okay, this is the error, this line there to fix. Like this is simple one, we take that and we resolve the issue. And the big one, it's too long. Right?
The job is
Okay. Plugin name. As I told you, plugin name are used as a namespace when you.
Yeah, this was the question we are discussing ourselves. Semantic kernel role exactly here to analyze this kind of issues,
Yeah.
So if like situation with the gone through that the matter came and we don't know exactly what the issue is.
So that's why this logging part is important, the tracing part, which will show you what's going on at the background and try to understand, check the functions, which functions are calling, what's the error message, exception handling. These are the important parts.
And we as a human being, you are able to understand what it's like.
Yes.
So why not this semantic kernel do something in behalf of you?
What do you mean?
I mean, kind of assistance,
Yeah.
Okay, there are issues.
Actually, it was, if you remember, it was trying to call the methods multiple times. And I believe we saw the same error 2 or 3 times. And it is trying actually, but every time it's failing and it stops in one point. It stopped and say that apologize, I couldn't read. Actually, it was trying to recover from the error message also. Actually, we have, yes, I'm going to show this one also, error messages in this slide. For a model to self-correct effectively, it's crucial to give a clear error message that indicate the issue and the steps to resolve it. So with that, this will allow the AI agent, AI service to attempt one more time to call the same method with the proper parameters, for example. That's crucial. That's why maybe it was my mistake to not to return a proper error message back to the AI, say that serialize the parameters to a pizza toppings, for example. Isn't it? Where?
The automation version. Where it fixes itself.
Yes, the first question was the same. Not get fixed automatically,
Yeah, in some cases, yes, it can automatically fix it.
It's a normal email error happen here. What we do, we copy paste and then we call that, right? And then fix them, rerun the algorithm. But why not? We have to need the same. We have to use it that thing.
This one costs money for one. It's going to cost money.
And
It's just long to figure out how long is that taking. So if you give it this capability, you have to be able to sustain how much it might cost you and how slow it might be. Also the fact that by trying to like infinite group of trying to fix itself.
yeah,
That's what happened.
yeah. So that's, yeah, when you start developing, you will see that it will, it might, yeah, it might get into the infinite loops. That's why it automatically stops it by itself. There's some, what they call circuit breakers. So it tries it maybe 3 times, and if it couldn't do it, and then it stops and returns that say that, sorry, I couldn't reach. So that's why the error type, the return types, error messages, or handling the exceptions properly and return a user-friendly or AI-friendly error messages back to the back and explain what kind of parameters you are looking for this function will be very helpful to OpenAI. By the way, for example, when I was developing this application, first I was using ChatGPT 3.5. It was behaving different. Then I changed it to the 4.0, OpenAI 4.0, and it starts working differently. So also the model that you are using also impact the performance and the quality of your application. Because it has
correction is going without backend. So maybe sometimes the same error will come if they will
exactly.
What he done with that particular
exactly. Maybe in the future, it's when we start using, let's say, OpenAI 5, right? 5.0, 6.0. Maybe we will not discuss this kind of things. Maybe everything will be, maybe most of the things will be handled automatically. Even the
about the DeepSeek now?
Yes.
Oh.
Since this one is recording, I don't want to discuss this one in this recording, but yes, I know about this one.
What's the error message that you usually get from your terminal? Don't usually make sense. So even if you give it to the AI, the chance that on a really big program, the chance of it fixing itself is going to be not always possible. Sometimes you get errors like, oh, this is the error. Gives you a message, but the message has nothing to do with the actual error.
That was the example that I've seen. Exactly as you said, the error is not even described exactly what's the error.
Yeah, because we are not properly handling the error here in the methods. There is no try catch actually in my methods, and I am throwing these exceptions back to the AI. it was like a real exception. As you can see, it was C# exception trying to serialize a string, convert the string to the enum, and it's failing. But normally, what in a production application, what I need to do is I need to handle this exception with a proper try catch, right? During my test, I need to catch this error. I need to handle it. If it is a convert exception, then I need to return a proper message, say that failing in the conversion of the pizza toppings to string to the toppings. So, and try. You need to try it. Explain it to the AI, what's going on. But you cannot be sure without trying, There is no single solution when we are talking about AI. Sometimes behave differently, right?
So that maybe the error messaging that we get is not descriptive enough to solve the problem, but there are AIs that solve the problems for the conflicts like collab or whatever other environment.
Mm.
So we could integrate that in the already exists.
Yeah. Maybe we can integrate a AI which is trained for the coding. Maybe, why not? Yeah. But again, this might give you a result of, this might give you an answer of answer with a coding practice, which you cannot do it in the runtime.
Also, sometimes if your program interacts with something outside of the program itself, say you're getting data from some source or you're getting data from some equipment, and for some reason something breaks here and here.
Yeah.
But it's going to fix itself.
True. Yes, that's true. There are lots of impacts from the outside also. The data itself also impacts the results also. Because it will be part of the response, the data itself. Yeah. So this is not a magic. This AI is not a magic. You shouldn't expect everything from this one yet. But hopefully, we'll see. Return types. Keep responses simple. Provide only the necessary information. Or summarize using another LLM prompt when possible. This will reduce the size of the response and keep it clean. So there are, as you saw in my application, when I here in the code, let me switch back to the code. When I define my function, I said that in the program CS, I said that function calling is auto. Function choice behavior is auto. And there are three different options here next to the auto actually. The first one is auto, allows the AI model to choose from 0 or more functions from the provided functions for invocation. The second one is required, forces AI model to choose one or more functions from the provided functions for invocations. I will explain why we need this required. And none instructs the AI model not to choose any functions. Again, there is a specific case to choose that one. So, but before I get into the details, this function choose behaviors, let's see which AI connectors supports the function calling and which are not. So as you can see, Anthropic, planned, Azure AI Inference coming soon. Currently, Azure OpenAI and OpenAI is supported with this auto function calling. The rest of them are planned or coming soon. So that's why if you are using any of the other AI services, you cannot use this function calling, auto function calling feature. then you need to do a manual one. Yeah. But yeah, it's coming soon, or it's planned. You need to follow what's going on. Okay. Yes, function advertising. It's the process of providing functions to AI models for further calling and invocation. And all three methods that I showed you can have the list of the functions as a parameter. So you can advertise it to the AI. By default, it's null. You don't need to give anything. It means that all the functions in the plugin which you registered and which has the kernel function attribute automatically advertised. You don't need to do anything. But in some cases, what you can do is, for example, in this case, this is auto, right? Let me see, how was it? See, yes, this one. Arrow. This is auto. It means that all functions from the date time utils. So as you can see, we are using add from type weather forecast utils and add from type date time utils. I have two class, right? Two plugin. One is weather, the other one is date time. Then I'm saying that auto, it means that both date time and weather forecast, we are advertising all the functions to this AI model if they are marked as kernel function. Okay, that's the first one. The second option is we give the name of the functions, the name of the method. You say weather forecast, date time utils, and we define the kernel function here. And then we said that in the weather forecast utils, use this method, and date time utils, use this method. Again, function behavior is auto, but I am saying that only these two functions, we are advertising them. That's the second option. And the third one is none. Why do we need it? You give it as an empty, you see. Already we create this, already we define this type, we add those plugins, but we say that function options auto, but null list. What's the point here? The point is it's disabling the function calling, and we are using this one for dry runs. For dry run. For example, you want to test the application and you want to see what is, so when you give an input, what AI is doing, which function AI will call with this input. You want to see it. But AI will never call this function. It will just show which function it's gonna call. It's a dry run. That's the purpose. Okay. That's the only purpose you use for the function calling. Yes. Another behavior here is that this is the auto. We already say that all functions from date types and plugin will be provided alongside with the prompt. It will go and call those functions. Required. What is required for? This is also interesting, and you use it in specific use cases. The required behavior forces the model to choose one or more functions from the provided function lists, and this is only for the first time. So you know that you have a use case, and in that use case you want AI not to decide by itself. you want to force the AI service to call the first function at the beginning of the application. You force it to call it, but only for the first time. Let's say your application is getting the weather forecast for a specific city. So for sure, the first method, the first function should be get city name, right? Otherwise, you cannot get weather information without the city name. So you know that city must be the first information that I need to collect from the user. That's why you are forcing AI to go and call this get city function.
It doesn't mean after calling this function, it couldn't call other.
Others, exactly. Otherwise, it will get into the infinite loop.
Okay, but it has another feature.
Yes, it's additional feature. Yes, you are, instead of letting AI to decide what to call at the first time, you will decide on behalf of AI, and you push it or force it to call your method. Okay. None, again, none is for dry run. To determine the color of the sky in Boston on a specified first call, the date time util current date time, blah, 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 blah. So if I convert this one, if I go back to here, and if I say that instead of auto, if I say none, save it, and if I go back to debug it, menu. As you can see, it didn't hit the menu function because there's a breakpoint over there, but it didn't hit the breakpoint. But it gives me what happens at the background. You see, chat history, user type, blah, blah, completion, function chose behavior none, auto invoke false, order preserve. These are the names of this prompt, and here the maximum limit of 0 auto reach. Of course, let me get the pizza menu for you, but it doesn't give me the. Yes, it didn't call it, but this tokens is from this chat history, the first call that I made. It's part of the history. Okay. Yes. It uses it, but it's less than the, if you call it. Yeah.
So now it's auto
Yes. It's for dry run. Okay. Function invocation modes. There are two function invocation modes. One is auto, the other one is manual. When AI receives prompts containing a list of functions, it may choose again from this invocation list. You can choose auto or manual. So if you say that it's auto, it will automatically call it. And semantic kernel or AI model choose which function it will call automatically. If you choose manual, if you want to put some extra more control over the function invocation process, you can use manual. So here, if I zoom here, auto invoke false, function choice behavior auto invoke false, and then chat results, check if AI models generate a response, response, and then get functions calls. For example, here, you see it will, let me see this one. It returns this one, function call can get function calls. It returns a list of the function call content. Okay. So as you can see, it says that check if the AI model has chosen any function for invocation. It will give me a list of the functions. Then what I can do is, as you can see, the name of the type is function calls. I will do a for each loop inside this function calls, and I will call them sequentially, manually. Or you can do a switch statement here, and you can decide which function to call by the name of the function, for example, instead of auto calling. Yes, it's a manual process. Let's say you know that at the, for example, you force the AI to call a specific method at the first try with this required thing, right? You know that the output of this function will be fork, a decision tree. So you can do a for each, or you can do a switch statement, and you can decide which one to call according to the result, for example, according to the use case. That's another scenario or advanced usage of function calling invocation. Text embedding. Fatma, what is text embedding?
So let's see what the audience already knows about it, and see how we can find the responsible for topic. Dive deeper to how you can do some of these things with semantic kernel. So I think some people already know because they recognize some pages from previous events. So Roa, tell me what you know about embedding. Well, what I understand, this is something that there are referred to be grouping of text before. Okay, I see what you're coming from. You think of like a chunking stuff that you might have looked at. Okay. Anyone else wants to give it a try?
Putting text into this.
Okay.
That is the switching and stuff.
Okay. So what does that mean? So basically,
kind of break up of that, right?
yeah. So remember when we talked about retrieval augmented generation in one of our sessions? Does anyone not know what RAG is? It's fine if you don't. Who here heard of RAG, retrieval augmented generation?
Yeah, we hear.
You heard of it, don't raise your hand. Yeah, you have.
I did.
You did it. Okay. So when you want to, you have the ChatGPT model or any AI model, right? You want to make it work with your data. Like, what's your name? Ahmed, right? Let's say you have your own information, or maybe like your daily diary where you write like your plans and everything, and you want the AI to be able to answer questions about that. How do you make that work, right? Basically, I want to ask it, hey, like, what did I do on the 5th of October at this, or give me any notes I wrote about, my gym tableau. So how do you ground the model on your data? We usually do something called retrieval augmented generation, right? So
you either mention that in the prompt, like have you worked with ChatGPT or any other AI models before? Yeah. Are you a student? Yeah. And if you're a student, you probably can't survive without it. Right? So basically how do you interact with it? You give like maybe some context at the beginning, which is the prompt, and then you ask it a question and then it will give you an answer, right? But let's say if you're a company or if you want to automate this better, you don't want to every time you give that big prompt to get the model make you answer the question correctly. You implement a technique called retrieval augmented generation. Basically, what that means, before you go to the LLM, you have a layer there that does retrieval. That basically, when you ask it a question, where was I on the 5th of October? It will go ahead to your database, but it's not any type of database. It's something called a vector database. Who here have heard of vector databases before? Sorry if you did it. So basically what's the difference between a vector database and a regular database is that in a vector database, you can store these embeddings. And what does that mean is, let's say if you have documents, I'm going to change the example. Let's say if you're a doctor, right? Are you a medical student?
Yes.
Yes. Okay, let's say if you're in another life, you want to be a medical student. So let's say if you have notes about, anatomy, all the medical stuff. And then you have a question like, what is the name for the scientific name for legs in anatomy? I'm just making something up. So before it goes to the LLM, you want it to go to your notes. So if you want the sentence that you have to retrieve from all the database that you possess, you do something called vector similarity. Exactly. All right. So when I type in the word leg, right? You might have taken your CS student. Maybe you've covered something called string similarity algorithm or string matching algorithm, right? So if I give you the word leg and I don't know what's something that's close to leg, like peg, right? These two words, if you do lexical matching, they're very similar. But meaning-wise, are they similar? No, not really. But if I give you the word leg and foot, or leg and tibia, right? That's the word for it. I don't know who here is medical. So tibia is, I think, the bone that's in your leg. So these two words, they're similar in meaning. How do you do similarity between meaning of words, right? Because you cannot compare string to string, like letter to letter, because L-E-G and T-I-B-I-A, zero similarity. But there is a meaning behind it. How can we retrieve that meaning? This is where we got to embedding. Embedding models, they've been trained on the whole, like a large amount of data sets. So for example, the entire Wikipedia. And in these articles, right, these words, they're mentioned in the same paragraph or within the same, like they're close to each other. So because it's seen it in a lot of documents close to each other, it knows that, okay, leg and tibia, they're close to each other. Or I don't know, king and queen, they're close to each other. The words pet, dog, vet, and animals, they're close to each other. So this type of similarity, you can do it with, that's where embedding models come in. Okay, so they're models that have been trained on a wealth of data where you get to see the occurrence of different words. And then it gets this is like on high level, there's way more that goes into it. But essentially, an embedding model takes the word leg and then it converts it into a vector. So a leg will be like a vector for class, just think of it as like a one-dimensional list, like 0.1, 0.5, 3, and 4. Like I'm just giving arbitrary numbers, but vectors are huge. Like I think the OpenAI one is like 1,500 something dimensions. So it's crazy. The larger it is, the more wealth it has, wealth of information and vocabulary. But this is on high level. So you need the embedding model to basically do retrieval. Okay, so that this way, when you ask it about, like what is the medical name for leg, it will go and retrieve. It will look at all of your the notes that you have. It will see where's the words that are close to leg, not just in like literally, but also in meaning. And then after you do that, then you get the relevant data. Like it does something called cosine similarity. There's different other algorithms where you can see the similarity between vectors. So there's also like dot product. If you've done some linear algebra, maybe you're familiar with some of these concepts. So then it just sees like how close, like maybe the vector for leg looks like something like this, and for tibia looks like this. So it sees the similarity between them. It's within a certain threshold. It's like, I don't want to get too technical. You can read more about it. But this is just on high level. Okay? And then once you get the relevant chunks or relevant paragraphs, then your LLM can answer, okay, yes. This is. You could think of it. That's one way to think of it. Like basically, the ones that are similar to each other will have similar weights. The vectors will have similar weights. So that's what embedding models are for. And then here you can see how you can do that. So embedding model is different from like a chat model, right? Chat models, they take in text and then they output text. Embedding models, they take in text and then they output a vector, right? And then you can take that vector and then you can store it into your vector database along with your chunks to do retrieval.
This is how you generate embeddings.
Yeah. So you can use this function. It just takes in this text and then it will output like a vector, and then you just store that vector into your database.
Okay. Question, Fatma, on behalf of everyone. So let's say we have a bulk of data.
Yeah.
Like we have hundreds of PDF.
Yeah.
And we want to vectorize them.
Yeah.
How are we gonna do it?
So you can write. How are you gonna do it on Azure? Or are you gonna do it in general?
General.
Okay, so you can write the scripts for it, right?
What kind of scripts?
Depending on your favorite language, of course, I would choose Python. So you would just take and you would parse the PDFs, right? So you would have you would give it a path where all your PDFs are stored, and then you would read through them, and then you would call your so before you pass it to the embedding model, you need to choose your chunking strategy. This is a whole topic on its own. You can watch some of our old lectures on this, chunking strategies, like how do you actually have a large, because why do we need to do chunking, guys? Can anyone answer? If you've heard of chunking, why do we even need to like split the doc? Why can't people pass all 100 pages to the model?
In one time, right?
Yeah, why can't we do that? Why do we need to do all this whole splitting out? Does anyone know? Exactly, because the models have limited context windows, right? So they're now there are with the whole rapid development that's happening. There's this just on a side note for you to know. Like there are some researchers that saying, hey, maybe you don't need all of that. Now with bigger and bigger models, let's just give everything. We don't want to just give it the chance. But no, it's not only about this. It's about the size of the context limit, cost, right? So imagine every time you pass 100 documents to the LLM, like each token costs latency, right? Because it has to every time parse all of that and then give you an answer. We don't want that, and also accuracy. Like you don't want it to hallucinate. We want to
generally financial sector. There are 100 PDF only one day, even 1 hour is ready, right?
Yeah.
Maybe 1 a month, I mean, thousands of thousands.
Yeah. And the older ones are maybe no longer relevant. So you want to get the ones that are more recent, the ones that are more relevant. So that's why the retrieval part is really important. The R and RAG, that's a lot, and just from experience working with a lot of customers, that's usually a challenge when you want to like put AI at scale. Like how do you actually, because a lot of the times the data is not always as clean as it is. You need to do a lot of work on it, making sure that you're getting the right data and not making it relevant.
So what's the point of
Yeah, you cannot do embedding. That's why I was saying, we need to do, after you choose your chunking strategy, like you say,
there is no point.
No, you can still see embedding models are not just meant for RAG application. There's other use cases for them as well. Let's say you want to create a
in this scenario.
Yeah, in this scenario, first it would be to like the stuff that the project said, if you have a bunch of PDFs and you want to create a chatbot on top of that, first you would take your PDFs, you would chunk them, you would choose your chunking strategy, then you would embed them, store them in a vector database like either Azure AI Search, Cosmos DB, there's other Quadrant and other ones which you can do it, and then after you store it there. Usually indexing is a one-time process or like a scheduled process, like depending on how fast your data refreshes. Then after that, then you would have your AI part or you build the interface where user asks a question, it hits the database to get the relevant chunks, and then it answers. It gets the relevant context and the user question, passes it to the LLM, and then it gives you answer. Does that clarify things?
And one more question, Fatma. There are different text embedding models on Azure OpenAI, right? Why do we need different models?
Yeah, good question. So it's a combination of cost, right? Some of them cost more than others, so you can take a look at that. And also the embedding model, the data set that it was trained on. So it's always better to use the more recent one because the have a richer set of vocabulary. So the latest one, the best one I think is the ADA embedding 3. Yeah. So it will be see that. There's also like some open source embedding models as well. So if you're interested in that, you can take a look at the Hugging Face embedding model leaderboard. Hugging Face, for those of you who don't know, is just where like everything open source AI, it's over there. And fun fact, using the Azure AI portal, you can easily deploy Hugging Face models just with a click of a button, including the new DeepSeek one that just came out. That would be the difference. And also some embedding models perform better in different languages, right? For like, for example, for Arabic, English, Hindi, or some other language, there's different, some of them they don't support other languages, some of them do, that's something. But for the OpenAI ones, they're the most expensive ones and
I think
for the best in the market.
Fanar is using very massive RAG for
Fanar.
the language point of view.
Yeah, so Fanar is like it's more like
because the Arabic, English to Arabic, the evidence of data is very less.
Mm-hmm.
So that's why they have this new RAG mechanism to index.
Yeah, so what the team at Fanar did is they just actually published their research paper. Maybe we can talk about it later.
I think soon we could have our own data inside and
yeah, sure. It's already out, by the way, like chat.fanar. It's interesting to see what they've done is essentially train a model, like the data set of the model, it's more curated Arabic data and more grounded in line with like athletic teachings or like more local teaching. So that's exciting. And if you want to do stuff like that, it's just so simple to do it on Azure, like fine tuning your own model. You have your own data set. You want to fine tune it on a specific use case or specific dialect, or maybe you have your own secret language that no one knows. You can easily do that. So for our project, we can maybe discuss it more.
they are open out, we open to it.
And do a language model.
Yes.
Is there something?
Yeah. So there we can we discussed this earlier. So we have RAG, right? And then you can also there's a whole other thing called fine tuning. Fine tuning is if you want to like avoid it every time you hit a database to get like relevant chunks, you want to sort of embed this knowledge in the brain. And for those of you who attended the earlier session, I gave the analogy of think of it if you guys are students. Who else is a student? So not a student. Are you also in UDSC?
No.
Oh, okay. So think of it, you guys, when you have an open book exam and a closed book exam. That's the difference between RAG and fine tuning. In open book exam, so you see a question, okay, you know which page to open, and then you see, okay, this is the paragraph they'll give you an answer, then you solve the answer. Okay, this is RAG. So every time you gotta open and then find, you don't memorize it. You rely on an external source. Closed book lab, the day before the exam, you gotta like shove it all in here and then just memorize everything. And then you just solve, everything is in there, like your neurons, everything has been altered to include that memory there. And then you solve the exam. So that's the difference.
This is the fine-tuning.
The closed book exam. Right? So you and that's what the team at Panar or other fine-tuned models did, is essentially they curated rich Arabic sources, they collaborated with different entities like POP, other professional library to get like they saw a gap in the knowledge of other LLMs, so that's what they did. And if you're interested, we can read more. There's a research paper that came out.
So, I'm gonna, if we're gonna fine-tune some existing model,
Yeah.
does it mean is it strong, to beat the one with someone with nerves from the
It depends. So there's different benchmark. And you also, another thing, gotta know, fine tuning is not that easy because you need a lot of compute power. All right, I guess Fatih wants to stop for a quick picture, right? So it takes a lot of compute power. You need a ton of data set, and it depends on the fine tuning technique that you have. In some use cases, fine tuning would work, because in a lot of the customers that we usually work with, RAG is the approach to go. It's very like niche use cases where you see that retrieval does not give good accuracy, then you would opt for fine tuning. But you need to make sure that you have the data set needs to be in a specific format, and there's some other prerequisites, and then you say into this.
Or not, because with all our
The use cases where you
what do I need to do it? Like to be able to some existing.
so basically you would take so any use case, right? So let's say you have data, like let's say you want to create a chatbot for like I don't know what's your favorite shop or show to watch, right? Like give me an example. Let's say if you want to watch the show Friends, like you could you basically can take all the data that's out there on Friends, right? Or maybe all the transcripts of the episodes, right? So then you can input them, chunk them, put them, run an embedding model on them, store it in a vector database, right? So you would need an embedding model, you would need a vector database, and then you would need the AI model that would actually read those answers and then generate. Yeah, so that's another part of it as well. So that's why some people maybe might go for fine tuning, because maybe they don't trust that model enough. They on the data that it was trained on. They want to train it on their own data so that it's grounded on their data. So that's something that you can apply. And then with Azure AI, there are certain features that you can enable to ensure responsible AI, to avoid jailbreak or prompt injection, all this other stuff. So these are all automatic features.
There are a couple of courses on particular requirement to learn much about the AI.
Yeah.
Like
So,
4 modules are there. If you complete that one, you will get
yeah, I can share it with you. And if you just go to learn.microsoft.com, and also if anyone's taking an exam soon or want to know, just let us know. We can give you discounts for taking
I
the
will go on with you.
Okay, do you already register?
I'm not registered yet, but
Okay, talk to me afterwards. We'll give you a discount. Of course. What was your name again? Muhammad. We met before, right? Yeah. So that's it. All right.
Thank you very much, Fatma.
Of course. I'll be here later afterwards if you go on.
Thank you for your time.
All right.
She's much better than me. Okay, cool. So there is a concept of filters in semantic kernel, but I'm not going to get into that one today because it's already 7:50. I think we are good. But basically, filters are the also ones who help us on the responsible AI point of view. So you can see what is going inside and what is going out, or you can block calling a method, or you can pass through by using these filters, which we are going to talk about next week. Okay.
So I believe in my personal opinion, filters be the most like minimized concept, so easy to handle the situation properly.
Yeah, you might need them because this is a necessary before and after function invocation. You might need to do some logging, exception handling, again, checking from the security point of view. That's important. But we will get into details next week, inshallah. Okay. Any question? Are we good? Okay. Thank you very much.
So much.
Let me stop the session.
For the online as well, what's the mean online? It's like
I am publishing it on YouTube also.